Hello students, I am Sailesh Prajapati. Today I invite to you in the chapter number 4, determinants. Students, in determinants today I going ahead our remaining questions in the exercise 4.5. Question number 11. Find the inverse of the following given matrix up to A 0, 1, 1, 0, cos alpha, sin with minus cos alpha. Very easy questions. First of all, I derived the determinant A and check them, that is non-zero or 0, then that declare for answer is exist. Go to our definition rule. They have to only cos alpha minus cos alpha. Now that you know, principal diagonal minus secondary diagonal minus cos square minus sin square, it should be minus 1, but non-zero. That means A inverse is exist. Now after that I will derive to all 9 cofactors by short method and go to inverse process. It's very easy. So now I declare 2 cofactors and adjoin. So students, first of all, basic definition is known shortcutly. Adjoint of A is a transpose of all cofactors. 9 cofactors I will check by shortcutly. These are 9, but these I take minus, very easy. This also minus, very easy. And these cofactors are first cos square minus and minus sin square, it is minus 1. Second, this t 0 minus 0. Third, again 0 minus 0. Next here this place, that and this, so 0 minus 0, very easy. Now middle, it is middle order, so minus cos alpha with minus 0, it means minus cos alpha. And last corner place, this one, that and this, sin alpha minus 0, it should be sin alpha. Now that one, this is the L shape, so 0 minus 0, again same, that is the sin alpha minus 0, so only sin alpha. And last, cos alpha minus 0, it is cos alpha. And students, that the transpose, you can cover your adjoint part. Yes, transpose, so minus 1, 0, 0, 0 minus cos alpha minus sin alpha, and 0 minus sin alpha cos alpha. So my target achieved, A inverse 1 upon determinant A into adjoint of A. Determinant A already you known, minus 1. So 1 by minus 1. But adjoint A, it means that one. Minus 1, 0, 0. 0 minus cos alpha, sin alpha minus. And 0 minus sin alpha with cos alpha. So does this minus, you can apply the inside. That will get 1, 0, 0. Now 0 cos alpha, sin alpha. And lastly 0 sin alpha with minus cos alpha. And that is your simple, your basic answer is done. Indirectly it is coming to again A inverse is equal to A. Good students. Now continue. Question number 12. Exercise same. Find the value for verify AB inverse by the property. Is verify that, very easy, AB inverse is equal to B inverse into A inverse. If A given 3 to 7 5 and B given 6 8 7 9. So very easy, I just calculate first this product with AB only, and then after inverse process I will start. So 3275 into 6789, and students just simple multiply. Yes, 6 3s are 18, 7 7s are 49. Next 6 2s are 12, 7 5s are 35. Similarly here product 8 3s are 24, 9 7s are 63, and 8 2 is 16, 9 5 is 45. That should be your answer. 8 and 9 17, 1 carry, 4 5 and 67. Here 5 plus 2 7 and 3 plus 1 4, 7 and 8 7 and 6 and 2 8, 6 and 5 11, 1 carry, 4 5 and 6 61. That is your simple AB. Now inverse process. So determinant of A, which is 67 47, 87 61, and that should be, you can calculate by the process either minus, either student 67 61 minus 47 87, and here coming one of the answer non-zero, definitely coming that. I think so it is a minus 2, because already I known here AB inverse determinant and B inverse determinant, and that I apply here. So now adjoint of AB, by mistake here written A, it is AB. So students, also I will define by determinant A 3 2 7 5. Here 15, 7 to the 14, it is 1. Same as determinant B 6 8 7 9, 7 9 9 6 is 54, and 7 8 is 56, it is minus 2. This two product is here coming. That's why direct written. Now students, your LHS AB inverse, which is 1 upon determinant AB into adjoint of AB. Very simple. 1 upon determinant AB is a minus 2, and adjoint of AB, it means this to AB. Principal diagonal, change their positions, 61 67, and secondary diagonal symbol change. That's the statement 1. Now I go to RHS. It's very easy. It is B inverse, A inverse, that I known. 1 upon determinant B, adjoint B, determinant A, adjoint A. Both determinant already I calculate. It means these are non-zero. It means this exists. Minus 2, B adjoint. Here 1, A adjoint. Now adjoint of B, it means this B. Take to direct adjoint, principal diagonal, change their position, 9 6, secondary sign change, minus 7 minus 8. Similarly A adjoint, here 5 3 and 2 7, just symbol change. Now it should be minus 2 and constant, and here apply your product rule. 9 5 is 45, this row and this column. 45 plus 16, next 7 9 7 and 5 35, minus 12. Now 9 7 is 63, minus 8 3 is 24, and last 7 7 is 49, 6 3 is 18. And check, this answer is same as to first one, definitely same. So minus 1 by 2, it should be 45 plus 16 61, minus 47, next minus 87, just check, and it is 67. 8 and 9 17 1, that is statement 2. Finally write down from 1 and 2. AB inverse is this are proofing, B inverse into A inverse, and that's the final answer. Very easy. Now continue. 13 1 3. Yes, find the A inverse and also verify by this two. To if A given 3 minus 1 1 2, and show that A square minus 5A plus 7I is equal to 0 matrix, and also hence find A inverse. Hence means using the above equations and derive the value, students. First of all, I go to A square calculation. A into A, 3 minus 1 1 2 into 3 minus 1 1 2, and going to simple matrix multiplications. So students, it is goes to 3 is a 9 minus 1 minus 3 minus 2. Same row to column. So 3 plus 2 and minus 1 plus 4. So 8 minus 5, 5 and 3. Now LHS start. That's your LHS. A square minus 5a plus 7i. Students, a square you known very well. Plus and minus 5 inside, a also known very well. And 7 with I known you 1 0 0 1. A also I known 3 1 minus 1 2. 3 1 minus 1 2. And last a square is this one. 8 5 minus 5 3. 8 5 minus 5 3. Now multiply inside. 7 also multiply inside. 8 minus 5 5 3. Here minus 15, 5 ones are 5, minus 5 and 10. Again minus 15, 5, minus 5 and 5 to the 10. So that is the last 7 0 0 7. Now you added all. Definitely it goes to answer 0 0. So RH is coming. In short, your half part is easily done here, students. Now using this equation, we will derive value of A inverse. That's very easy. Just only I operate this equation. Therefore, A square minus 5A plus 7i is equal to 0. Now using this, I will derive A inverse. It means we multiply both sides. Multiply A inverse on the both side. So here A inverse to each term multiply, A inverse to 5A multiply, and A inverse with 7i to multiply both the side. So easily you derive your A inverse. So here this answer is A raised to 1. This and that identity. So minus 5i. Here I with anything, it is anything. So what do you get? 7a inverse, 5i minus a minus 5i, convert right side. So it will be covered to answer 51001 and minus a, it means this a you convert into minus, minus 3, 1, minus 1 and 2, minus 3, minus 1, 1 and minus 2. Now just calculate 5005 and here minus 3 minus 1, minus 3 minus 1 and 1 of minus 2. Now both added. So students, 7 of A inverse, it is 5 minus 3, 2, 0 plus 1, minus 1 and 5 minus 2, that is 3, divided by 7. So finally your answer is done. 1 by 7, other is a 2 1 minus 1 3. If you going to adjoint wise, then also same answer coming. Just see principal diagonal change, secondary symbol change, and modulus is a 6 plus 1 7. But here asking by show, calculate by the equations. That's why our students multiply A inverse on both sides. Continue. 14. Same process running and very easy questions. 14th one. For the given matrix A and equations, find out A and B. So for matrix A, 1 1 2, 1 2 minus 1, 1 minus 3 3. Sorry, by mistake I written. 14 is a 3 2 1 1. Find A and B such that A square plus A into capital A, B into I is equal to 0. Yes, A square plus AA plus BI is equal to 0. Very easy students, just only define a and b, but I go to first a square calculation. So a square is a into a 3 to 1 1 and same 3 to 1 1. One more time I check 3 to 1 1. Now students, row to column, just multiply. So 3 3 is 9, 2 1 is 2, 3 1 is 3, 1 1 is 1, 3 1 is 3 and 1 1 is 1. Last 3 2 is 6 plus 2 1 is 2 and 2 plus 1. It is 11, 4, 8, 3. That's the a square. Now these equations put in here, they get to answers. So from given a square plus a into a plus b into I is equal to 0. Only apply the a square. 11, 4, 8, 3. What is the a? A is a 3 to 1 1 and b, I is a 1 0 0 1, and this side you just follow your 0 matrix. All elements are 0 0. Now go to final solutions, and very easy. So my solution is this a multiply inside, b also take multiply inside. So remainings are 11, 4, 8, 3, 3a, 1a, 2a, 1a plus b 0 0 b and is equal to as it is. Actually you getting here two linear equations, then after solutions. So 11 plus 3a plus b, 4 plus a plus 0, 8 2a 0, 3a b and is equal to, just you compare it. I think first comparison is best way. 4a plus 8 is 0, 4 plus a 0, a become minus 4. Either you 8 plus 2a compare 0, 2a become minus 8, a is minus 4, indirectly a coming. Now b, 11 plus 3a plus b 0, just you put it a minus 4. So 11 minus 12, it is minus 1, so b become 1, and that's your answer. But must be checked last equation also as well as 3 plus a plus b, a become minus 4, so minus 1 plus b, definitely you cover b is equal to 1. That all are compare and answer check a and b are equal or not. And students, here our this question is easily 15 also done. Now after that I am moving to my next questions. Now students, continue. I going ahead. Question number 15, 1-5, which is the biggest questions, an exam oriented IMP in the 4 marks. So question is there, for the given matrix A, to given 1 1 2 1 2 minus 1 1 minus 3 3, and first of all show that, one more time check, 1 1 1 1 2 minus 3 and 2 minus 1 3, a cube minus 6a square, 5a 11i is equal to 0, and hence find a inverse. Just going to a inverse value is a cube minus 6a square, 5a plus 11i. Just I calculate first a square. Very easy. A into a, 1 1 2 1 2 minus 1 1 minus 3 3, and again 1 1 1 1 2 minus 3 and 2 minus 1 3. So does this row wise column entry. So first entry is a 1 1 and 2, second 1 2 minus 6, third 2 minus 1 plus 6, Now second entry, 1 ones are 1 plus 2 ones are 2 minus 1 ones are, next 1 2 twos are 4 plus 3, and last 2 minus 2 2 minus 2 and minus 3. Same as students last column entry, it is 1 minus 3 plus 3. Continue, 1 minus 6 minus 9, and last 2 plus 3 plus 9, 2, now 3, and last 3 is 9. So a square is gone easily, 4, next minus 3 and 7, here 2 and 7 and 1 8 and minus 3, and lastly 1, here minus 15, it is minus 14, and 5 and 9 14. Yes, that is the known to 4 to 1 minus 3 8 minus 14 and 7 minus 3 14. Yes students, that is a square bond. Now I go to a raised to 3. Same as a raised to 3 a cube. Also we can derive a cube is a square into a. Just put it a square and putting the a. A square is known, 4 to 1 minus 3 8 minus 14 and 7 minus 3 14. 4 to 1 minus 3 8 minus 14 and 7 minus 3 14. A known also, 1 1 2 1 2 minus 1 and 1 minus 3 and 3. Again students, same entry, row to column. This row first, column first. 4 ones are 4, 2 ones are 2 and 2 ones are 2. Next 3 ones are 3, 8 ones are 8, 14 twos are 28. Now 7 ones are 7, minus 3 and 28. Similarly second column. Now entry, 4 ones are 4, 2 twos are 4 and minus 1 ones are 1, minus 3 plus 16 plus 14, and last entry 7 minus 6 minus 14. 7 ones are 7, 3 twos are 6 and 14 ones are 14, and last 4 ones are 4 minus 6 plus 3, and again minus 3 plus 8 3s are 24, minus 3 8 3s are 24, and last 14 3s are 42, and last 7 ones are 7 plus 9 plus 42, and that's your a cube value. Easily you just plus or minus taking and get the answer 8. Here are 3 5 minus 28 minus 23, and last 4 and 28 22. Second 8 minus 1 7. Here 30 minus 3 27, and here 1 and 1 minus 14 minus 13. Again repeat, here it is 7 minus 6 1. Last of the 42 27, 24 and 27 and 42, 7 and 2 9, and 4 and 2 6 minus 69, and last 7 and 9 16 and 42, 8 and 58, and those all values 8 7 1 minus 23 27 minus 69, and last 32 minus 13 and 57. These are the mistake I think. 7 and 9 16 and 58. Yes, it is corrected. Total answers. And now final answer, 7 1s are 7, 3 3s are 9 and 14 3s are 42. Yes, 16 and 42, 8 5 58 correct. So now I start my LHS. Students, this is your LHS, a cube related, a cube minus 6a square 5a plus 11i, and value put it. A cube no new, minus 6 also a square no new, a also known, 11 and I also known. So does my a cube is ready. 8 7 1 minus 23 27 minus 69 32 minus 13 58. A square is that much, 4 to 1 minus 3 8 minus 14 and 7 minus 3 14. A also known students, 1 to 1 2 1 2 minus 1 and 1 minus 3 3, and I known 1 0 0 0 1 0 0 0. Finally you multiply inside to each data. So 871 minus 23 27 minus 69 32 minus 13 58 minus 6 make inside. So 6 4s are 24, 6 3s are 18, 7 6s are 42. Next minus 12, 8 6s are 48 and 6 3s are 18, minus 6, 16 6s are, yes 16 6 14 6s are, 6 4s are 24, 2 carry, 6 1s are 6, 7 and 8 84 and minus 84 here. Continue. 5 5 10, 5 10 minus 5 and 5 minus 15 and 15, and finally 11 0 0 0 11 0 0 0 11, and this all entry if you add it, surely you can make the answer is 0. So is all total entry, you will take 0 0 0 0 0 0, it's a 0 matrix. Therefore you will prove a raised to 3 minus 6a square plus 5a plus 11i is equal to 0. Using this equation, now I will derive to a raised to minus 1, and that part is useful in the solution wise. So I will start now. We multiply both sides. A raised to minus 1. So here a raised to minus 1 with a cube, 6a square with a raised to minus 1, again 5a with a raised to minus 1 and 11i with a raised to minus 1. So here a square coming, it is 6a, that is the I. Here I with anything, it is anything. So 11a inverse is as much as simple, this take right side, minus a square plus 6a minus 5i. Now minus as it is a square, 6a and your 5i, 1 0 0 0 1 0 0 0 1. A is known you. What is your A? Yes, that is your A. 1 1 1, 1 2 minus 3 and 2 minus 1 3. And last a square also known you, 4 2 1 minus 3 8 minus 14 and 7 minus 3 and 14. Now multiply inside. So 11a inverse, it is minus 4 minus 2 minus 1 3 minus 8 14 and minus 7, it is 3 minus 14. 6 also you make inside, 6 6 6 6 12 minus 18 and 12 minus 6 18, that much also you multiply inside, minus 5 0 0 0 minus 5 0 and 0 0 minus 5, and these calculations you will get your A inverse. Finally done. Indirectly this numerical also students 4 marks, totally 4 marks level this questions asking. Now you go to final answer. So 11a inverse, just you make subtraction, minus 4 6 and minus 5. So 6 here 2 and minus 5, it is minus 3. 3 plus 6 9 and 0. 7 minus 12 and 4 is 5. Minus 2 6 4. Now minus 8 12 and minus 5 is goes to 8 and 5 13, 13 and 12 minus, it is a minus 1. Last 3 and minus 6 minus 3. Now minus 1 and 6 and 0, it is 5. And last 14 minus 18 0 minus 4 and minus 14 18 and minus 5, 14 and 5 19 minus, it is minus 1. So A inverse is done 1 by 11, just as it is write down, 5 minus 4 minus 1, and that's your answer, minus 3 4 5 9 minus 1 minus 4, and here last of the 5 minus 3 minus 1. So it is 16 question, you self calculate. Homework. Now 17. Let A, these two MCQs, be a non-singular square matrix of order 3 cross 3, then asking adjoint of A is dash dash dash. An option printed. You have to determine A square, A cube, and D 3 of determinant A. So does adjoint of A define and the determinant? Answer is must be yes, this one. I just give you a short formula. Whenever you given adjoint of dash 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 k times of A, then you can apply determinant A raised to n minus 1 raised to k. This is a very short formula. Here given adjoint how many times? 1 times. N indicate this. This is your n. So apply the formula. Only determinant A raised to 3 minus 1, but k is 1. It is square. It is direct answer. Either go to cofactor and process is very lengthy. Okay, but this formula by heart for any adjoint up to k times means number of times adjoint, that is the k, and n is indicate number of row and the column. Now 18 also very easy. If A is the an invertible matrix of order 2, then determinant of A inverse is equal to dash dash dash. Here also first of all write the options. Determinant of A, second 1 upon determinant A 1 and 0. Students, determinant of A inverse means A inverse you know process. Yes, A inverse is what? 1 upon determinant A into adjoint of A. But I want to this determinant. So determinant of A inverse. So that whole parts I will take also determinant of A. So that is your determinant of A inverse. Here 1 upon determinant is same. Here determinant of adjoint of A. And that I already explained here. So apply the value. It is what? Determinant A square. This cancel. Your answer is only determinant A, and that is your answer B. Sorry, answer is A, not B. It is A answer. Because A coming no determinant. Yes, determinant of A. And check your answers. Answer is a 1 upon determinant A, because my mistakes. Students, here this is value for A inverse is a coming that 1 by determinant A, and determinant A is as it is, and that value is a square. Yes students, your answer is determinant A only. And here our this questions easily students I have to done. Students, by mistakes here I written the wrong answers, because your adjoint of A here how many times given? 3 times. Therefore here write down 3. But here what given? It is 2 cross 2. So here you write down the formula determinant A is to n minus 1 is to k times. I mean determinant A, n is a 2 minus 1 raised to 1. In short, my value is only and only here. It is a 1 times determinant A. So your answer is not this one. Your answer is this one, 1 upon the determinant of A. And that is your students final calculations done. Now students, here our this exercise is happily over that, and this part I stop here video students. Further explanation I explain you in the next parts. Okay, bye bye. Now students, otherwise this also you calculate by the different method. You know that A into A inverse is equal to I. This property also you can apply in place of that. So if you not calculate this method and you going to by this rule, Then also students, correct way at the solutions. We know that A into A inverse, which is I, and both side taking just determinant of I, and that is your determinant A into determinant of A inverse, that is 1. So what is the A inverse determinant? My target is A inverse determinant, which is 1 by determinant A. So that's why you write down determinant of A inverse, which is 1 by determinant A. And here students, this answer is done. So by mistakes in the first calculate, I wrong calculate, and here students, your this exercise happily done here. Students, I stop this video and further explanation I explain in the next parts. Okay, bye bye.